What if I told you that every major breakthrough in physics was painted before it was proven? Not illustrated after the fact, not inspired by the science, painted first, decades before the equation existed, by artists who had no idea what they were predicting. That's the argument Leonard Shlain makes in Art and Physics. And once you see the evidence, you can't unsee it. This is the untold story of how painters saw the future before scientists could prove it. The story starts with the Greeks. Around 300 BC, Euclid codified space into geometry flat, infinite, governed by straight lines. Aristotle formalized logic. Pythagoras married mathematics to reality. The Greek artists mirrored all of it: linear figures, geometric proportions, buildings designed with mathematical precision. Together, the philosophers and artists built a framework. Space is flat and absolute. Time is constant and unchanging. Light bounces off the walls of this grid like a ball in a box. This framework lasted 2,500 years. It survived the collapse of Greece, the rise and fall of Rome, and 1,000 years of religious darkness in which reason was replaced by prophecy and paintings, became flat, golden icons with no shadows, no perspective, and no spatial logic. Then came the Renaissance, and the first person to crack the code was not a scientist, it was a painter. Giotto, around 1300, was the first artist to paint a scene from a single viewpoint, creating the illusion of three-dimensional space on a flat surface. A century later, Piero della Francesca painted shadows cast by directional light, proving visually that light travels in straight lines. This was 200 years before Newton and Leibniz investigated the same question with mathematics. Leonardo da Vinci and Isaac Newton were parallel minds separated by 2 centuries. Both operated at the highest level of abstraction. Leonardo drew the future, Newton calculated it, but the painter was there first. Now, here's where the story gets extraordinary. By the 1860s, Newton's universe seemed perfect. Space was flat, time was constant, light was relative. Every scientist believed the grid was real. But the painters were seeing something different. Manet broke every rule of perspective. His figures were flat, compressed, illogical. In one painting, he curved the line of the sea along the horizon. This was 50 years before Einstein would prove that space itself is curved. Monet stopped painting objects. He painted the same haystack, the same cathedral at different hours, capturing how time transforms everything it touches. He was painting the dimension of time as a subject, decades before Einstein fused space and time into a single continuum. Cézanne went furthest. He painted objects from multiple viewpoints simultaneously, the front and the side of an apple in the same frame. He treated empty space as if it had weight and geometry. 40 years before Einstein proved that empty space is not nothingness but a flexible fabric, Cézanne was already painting it that way. Then, in 1905, Einstein published his special theory of relativity, and his three conclusions matched what the painters had already shown. Space is not flat, it warps and contracts. Manet had already shattered flat perspective. Time is not constant, it dilates and stretches. Monet had already painted time as a fluid, shifting dimension. Light is not relative, it is the only constant in the universe. And at the same moment, the Fauvists, led by Matisse, were elevating color, which is visible light, to the supreme subject of painting. Monet himself said it: light is the real subject of every painting. Cubism arrived alongside relativity. Picasso and Braque painted objects from every angle at once, the first alternative to Euclid's view of space in over 2,000 years. The futurists attacked linear time, collapsing past and future into the present moment. The artists and the physicists were solving the same problem, they just used different tools. And the pattern didn't stop. Quantum physics revealed that matter is made of invisible energy fields. that particles are also waves, that the act of observation itself changes the result. And at the same time, painters like Pollock and Reinhardt abandoned the image entirely. They didn't want to depict a thing in space, they wanted to capture the moment of now, the same now that Einstein showed dilates at the speed of light. Reinhardt painted black squares and called them breathless, timeless, and endless. Before astronomers even located the first black hole, artists were painting what it would feel like to stand at the edge of one. Schlain's conclusion is simple: art and physics are parallel investigations into the nature of reality. The artist sees it through image, the physicist proves it through equation, but the painter always sees it first. I'm Ronnie, and this is the untold history of how art predicted physics. Next time, we'll dive a little deeper into our brains and how we behave as humans.